Coming up on This Week in Radio Tech, we've got him. He's awake and alive. It's staying up late past his bedtime. It's Patrick van den Hoek from Amsterdam. He runs 13 radio stations in Spain and has some great technical ideas for us. He's coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionic Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. By Nautel, worry-free transmission you can count on with outstanding control, reliability, efficiencies, and Nautel's unmatched 24/7 customer support. Online at nautel.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower. And look at this. I came unprepared. I can see right now my TWiRT sign is off. Oh, shame on me. I got it. There we go. I gotta pay the roadie crew more. Welcome in. Glad you're here. I'm Kirk Harnack in the Telos Alliance studio in Nashville, Tennessee, where we've got a storm going on outside. So if I lose power, well, you know, Chris Tarr will just take over the whole show. He might do that anyway. Chris Tarr, welcome.
Hi there.
Good to see you.
I got to get my Kirk Harnack gray wig in order to do that. And, the perfect hair wig. And then, I've got the glasses. My glasses are very similar. And then we were just talking about how, I've got to drop my voice down a couple octaves to get down to Kirk, like that. So anyway, yes, greetings and salutations, Mr. Harnack, live from the Chris Tarr basement, or as I like to call it, the basement of love down in Mugwanago, Wisconsin. Hey, now, I don't know where you're going with that, but, come on.
You must be talking about agape love. You're wearing your Brook Life shirt.
Yes, exactly. Yeah. This is actually my office. This is where I do when I'm not driving around. And you can see back there, there's my office assistant. I got to figure out which way to go there. Louis, laying on the couch. My yellow lab. Yep, he likes to hang out with me. As long as he doesn't I just let him out, so he shouldn't be yelling at me halfway through the show, like he's been known to do. I've called HR about that, and we've got that worked out. So so we're doing well, and good to see you. Good to be back again.
So I never realized you do have glasses that are very similar to my frames. Do you normally wear those? And I just didn't notice.
I actually have two pairs. This is the one I wear usually just working because they're kind of older, and then I have the big ones that I wear. Usually
that's what I've typically seen. And you posted a picture of some green big glasses recently. What's that about?
Well, and I guess I can say it here since nobody guessed what I was. That's for I take my daughter to Comic-Cons all the time, all through the year. And this summer, she convinced me to do a costume. So I don't know. Have you ever watched Mystery Science Theater 3000?
I have, yeah.
Okay. One of the guys, Dr. Forrester, wears those green glasses. So that was kind of a hint as to what my getup is going to be. That part of the costume is going to be the green rim glasses.
You could carry a couple tires, and instead of being Dr. Forrester, you could be Subaru Forrester.
The dad jokes have begun. Here we go.
I'll in the show notes, I'll post a link to Dr. Forrester so people can preview your glasses.
It's a geek thing, and so I'm sure a lot of the people viewing know exactly who I'm talking about.
I've probably seen Dr. Forrester, just kind of forgot. So good. Glad you're reviving Dr. Forrester for Comic-Con. And that's great that you go to that with your daughter. Hey, let's go ahead and bring in our guest real quick here before we take our first announcement. And that is Patrick, and I hope I say it right, van den Hoek. Captain Hook. Hey, welcome in. Good to see you, man.
Hey, good evening, everyone, or good afternoon in the U.S., I guess, or I'm not sure.
It's past your bedtime there, isn't it?
It is now 5 minutes past 11, so yeah, it is bedtime, but yeah, it's okay. I'll have some free time with you guys, and it's Patrick van den Hoek. So,
Van den Hoek.
Hoek. Ooh, like ooh.
Ooh. Hoek.
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 It's difficult to pronounce. I know. I know.
Whenever I hear people pronouncing words in other languages, I think of how lazy American pronunciation of darn near anything is. We just, whatever, if you can pronounce it without moving your mouth very much, we're going to do it that way.
Well, that's really more of a Southern thing than a Northern thing.
Okay, you're right.
I've heard, Southerners, they like it. They don't cut something in half. We're going to cut it half in two. Stuff right. like that. They don't move their mouths down south. I'll tell you, they turn their mouth up and when they're talking.
Sounds like Peter Griffin.
Exactly, yeah.
Patrick is on the show because Patrick is one of these amazing dual, triple, quadruple role individuals in radio. But one of the things that Patrick does is he is a broadcast engineer, and I want to find out what Patrick's doing to run 13 radio stations and make them all sound good. So, Patrick, give us a little elevator, give us a little tease about what you're going to be telling us about your operations, your radio stations.
Well, I broadcast with 13 radio stations, and I make money out of them, as you have seen in the promo yesterday. Yes. Kirk is doing the same thing with one more and doesn't make any money out of it. Well, we're going to talk about how to transport audio in mountainous areas and a really creative solution to have ad breaks that are split for different regions to not make your radio sound like it has a CD with scratches on it and skipping all the time during the ad break or even during the music. So a lot of technical topics we're going to cover. So those are two of them, and there will be probably more. Yeah.
I have a little bit of a clue as to the technique you're talking about, and I want to fully understand it as you're going to explain. But for split, when you split advertisements on different FM stations that maybe overlap, you've got this very clever way of making sure that people that their radios no longer flip between two stations and they hear two different. Yeah, yes. This is Chris. This is so cool. And I think, Chris, about stations that you've worked for where you have, like a chain or a ring of stations around a metropolitan area, where I don't know if you ever, sent main programming out to everybody, but whenever there's a commercial break, you split off, right?
Yes. Oh, yeah. We do that a lot, although it's not, generally we're not close enough to do the networking where we just do the handoff with AF. We have AF, but we're not really close enough to where, we're worried about the radios switching back and forth, right? Because usually you're completely out of one signal area before you're into the next. So and I'll be interested to hear more about this.
And for those who aren't quite up to speed on the terminology, AF means alternate frequency. It's transmitted as part of your RDS stream, and it's telling your radio that has RDS, hey, if you lose this signal from this transmitter, here's another frequency to go try. And you should be able to pick it up there instead. And you can have a list of alternate frequencies. And my introduction to AF was in France, literally 25 years ago, where you have a little transmitter in each village. And it works great. You just tune the radio once and you can drive all over the place. And it just flips to the correct station basically seamlessly. So we're going to talk about that and this really clever modification of AF that Patrick's talking about, plus plenty of hilarity coming up. Hey, This Week in Radio Tech is brought to you in part by my friends at Nautel. They should be your friends too, especially with regard to Transmission Talk Tuesday. It's a roundtable discussion about some engineering topic, usually having to do with transmitters, transmission systems. And let's get a quick clip here, a little topic from Jeff Welton and Nautel's Transmission Talk Tuesday.
So how do you pack tools and equipment so you can load it and unload it easily? What I finally, after a couple of years, what I ended up doing is buying one of those rolling tool kits. They make them. What I happened to get was from Home Depot. They make every company's got one. I went for the lightest but the most durable. And it's a 3-part box. Is the best I can explain it. It's like on a rack, it looks like a a furniture dolly kind of, rack. You pull it down like your luggage. So there's a big box at the bottom, then there's a medium-sized box, and then there's a small box on the top. So what I could do is I can sort that so that the bottom box, which has got the wheels and the handle, I fill that up till it's 50 pounds with some of the larger stuff that I need. Then the second box, the same way, and then the top one is typically a lot of smaller things, small tools, connectors, that kind of stuff. And then for my purposes, what I can do is I can take the lower box is 50 pounds. I take the top two boxes and I strap them together. Those are 50 pounds. Those come apart. And so then at the airport, then I can check those. And then I can have a third box, which is typically my, because I'll be gone, in most cases, unless it's just the one here, I'll be gone for at least a week. And so that'll be like, I'll have my suitcase, which will have some clothes. I put some snacks, food, and things like that. And then I fill that up, the rest with the 50 pounds with other equipment, test equipment, or tools and things like that. And then, of course, you have carry-on, so I can carry my laptop in another carry-on bag. And that typically, sometimes gets heavy, but it's easy because it's a rolling rack.
And you'll hear lots of tips like this during Transmission Talk Tuesday. Go to nautel.com/webinars. Nautel.com/webinars. Click on Transmission Talk Tuesday. Every Tuesday, Jeff Welton hosts a roundtable discussion, and you can participate too if you like. You can raise your hand, you can chat, you can ask a question. And this month, they're talking a lot about IT issues. Last week, this past Tuesday, was VPN and how to set up VPNs and different kinds of VPNs. Really educational. This is great programming for us broadcast engineers. Thanks a lot, Nautel. Nautel.com/webinars. We're sponsoring This Week in Radio Tech. Okay, we're here with Chris Tarr and Patrick Vanden Hoek. Hoek, hello.
Hoek. Yes, that's good.
Okay. I'll get it right eventually. Well, Patrick, okay, set up the problem for us, and then let's talk about the solution to the problem.
Well, let me first give you a little background information on how I will get to the problem, because
Sure.
7 years ago, I took over a company. I purchased and took over a company, just to be clear, because the previous owner decided to sell the radio stations. And I was like, oh, no, that's not happening. And I was doing some little IT-related stuff before that for the same company. And yeah, I would be in tears if the company went off, and I wouldn't be working there anymore as an IT guy. So when I came to Spain, because we're talking about Spain in this case, because a lot of people know I'm from the Netherlands, but we're now in Spain. The main problem there was transportation of audio in good quality. Because like in a lot of mountains and transmitter sites, you don't have a great internet connection, for example. You have ADSL sometimes with 1 megabit up or down, and it's not stable at all. So you cannot rely on that for 24/7 broadcasting, of course. So yeah, that's the first problem we can talk about, like how to get the best possible audio to your transmitters in a simple way.
Okay, so you have me intrigued. How do you get audio?
Well, a lot of radio stations in Spain, when I first came there, it was 2009 or something. I heard that a lot of radio stations still use those old Barracks X and in streamers to transport their audio to the transmitter.
Sure.
But it all sounded like it was a bad MP3 you downloaded with LimeWire or Kazaa or iMesh. I don't know what we used back in the days to download music. But my main concern was, okay, what is going to happen when I take over and purchase the company? What will be my main goal to do first to optimize, well, things like sales, marketing, or etc. But my main concern was the audio, because the audio sounded bad, and that's an understatement. They were using Barracks in an X streamers, which are great devices, but not to put in your analog input of your transmitter and just broadcast it like with no clipping, no RDS included, etc. It was horrible. So, well, years ago, when I was there, my main question was, hey, how can we optimize this? Because we don't have a proper internet connection or even no internet connection on some of the transmitter sites we are using. And they were like, hey, yeah, but we're doing this for 15 years and we use a simple Wi-Fi connection to transmit the audio through a Wi-Fi signal with 5 gigahertz to the transmitter or mountains. And I was like, oh my goodness. Like, for example, in the Netherlands, we don't know internet streaming or barracks for broadcast. We use or fiber lines, or some of them use satellite up and down links, but it's, in my opinion, an old-fashioned way to distribute audio. So the main goal, audio quality, because I hate the sound of MP3, the dithering, the and decoding process that is going on, which is horrible. And I was like, let me try and put up some antennas from the office towards pointing towards the mountains, and just try and use audio over IP. To give you an image, the distance between, I don't know how much it is in feet, or how, is that your metrics in the US? Feet, right?
Feet, and if you talk meters, we'll figure it out. But
yeah, we talk in kilometers. But like, for instance, for one of our frequencies, the distance between the office and the transmitter site is like 12.5 kilometers. And that was a really interesting thing, because audio over IP normally requires cabled internet, not of Ethernet, sorry, and no Wi-Fi, because that wouldn't be stable. You would have package loss, etc., and all the horrible things that may happen between the office and the mountains, because there's interference. A lot of Wi-Fi is going on in Spain as well, because they provide internet access for home through Wi-Fi still. So yeah, that was my main concern as well, how to transport audio to the transmitter in good quality without any problems and a stable connection. The first day I put on those antennas, one on the mountain and one pointing towards the office, I just tried out a demo of Livewire. I remember Marianne got in touch with me, and we were already testing some processors, etc. So we were already in touch with each other. I tried Livewire, and I thought to myself, oh, I'm such a moron. This is never going to work. What am I doing? I'm wasting my time. But I configured everything. It was really simple. One end Livewire, at the other end Livewire from an Omnia 9SG, which we have on our transmitters. And the audio was like HD plus. I don't know how to describe it, but it was just imagine MP3 192 kilobit to linear audio.
Right,
that's just a fairy tale if you talk about Wi-Fi, but it worked out really well, and it's still working. We had like 2 dropouts, like tiny dropouts in 1 year. So that was during a large storm and rainstorm. So
Patrick, let's pause right there. Let's examine a couple of things you mentioned. You mentioned something a few minutes ago, Patrick, that I think is very interesting. And Chris, you may have seen this yourself. You mentioned that in Amsterdam or in the Netherlands, you would never use a low bit rate coded audio as your STL. You would use some form of linear transmission, maybe just a regular RF radio, an analog radio, like a lot of people use here, the 950 megahertz band, whatever band you use there, or fiber or something. Whereas in many other locations, countries, areas, maybe MP2 or MP3 over a phone line, over ISDN is perfectly acceptable, and it's the norm. And it's interesting how this can be regional. Like people say, oh, we don't sound any worse than that station over there, and so it's okay. And if you do something, and you realize, some people like you, Patrick, will realize that's not okay. It's got to be better than that.
It isn't.
It can be better than that. Yeah. Chris, do you find regionalization yourself as to what's acceptable and what's not acceptable?
Oh, sure. I mean, it's always, or can get into being a race to the bottom in a lot of cases. But my experience has been a lot like his in that, we do a lot of IP radios to a lot of our sites. Now, some of them just by nature, we do reduce the bit rate. The lowest I'll go is 384 AAC, which is just about as close to linear sounding as you're going to get. But I do have some hops where I have really good connections and I'm able to do linear audio from start to finish. And, that's certainly better than anything you're going to get from an RF composite STL or even a digital STL in the 950 band, because it still is, bandwidth limited. So, we've been moving a lot to these IP radios because they've gotten to the point now where they're reliable enough to where I'm not, super concerned about, having, major failures with them or dropouts or anything like that. But yeah, I mean, there's a lot of places where we've come into town and, with my group now, and we've put in new processing, or even the people before me, the owner of the station is a very big audio guy. So even before I got started working with him, they started putting in Omni 11s and 9SGs and things like that. And I've continued that where, we'll come in and we'll buy a new market or buy into a new market. And, first thing we'll do is replace audio processors, RF links, some cases exciters, anything to, make those incremental improvements in audio. So yeah, I agree with Patrick 100% in that, it can be a race to the bottom if you let it, because, if we come in and don't do very well, then our competition is going to go, well, we don't have to do better than that. And, everybody, kind of races to the bottom. Whereas I use the phrase, the rising tide lifts all the boats. So
right.
Whenever we come into a new town, we try to do that, and we try to, raise the tide a little bit and make radio in general better, because we're competitors between each other, but we're also competitors with, Spotify and TV and satellite radio and all these other things. So if what I can do, makes our competition, rise up a little bit better and change theirs, everybody wins. So that's kind of the way I look at it.
Hey, we're going to take a run to break here for just a second, and Patrick is going to continue with his story. I want to clarify something, though. Patrick uses the term Wi-Fi, which is what they call it there, whereas, at least in my little world, it's Wi-Fi technology, but it's a point-to-point IP radio. So when exactly. Patrick's saying Wi-Fi, what he's really saying is a point-to-point IP radio, which they use typically Wi-Fi technology, especially if you get something from Ubiquity. Yeah, it's a Wi-Fi radio, but it's got this dish and a feed horn on it. And
it's huge.
So, and yes, years ago, I started putting LiveWire over that. I had to experiment a lot to find the right settings. And the one thing I would point out, at least my experience, Patrick, is if you want something like LiveWire or AES67, any kind of linear audio over IP to go over an IP radio, you've got to turn, well, I think you said you didn't have to, but I had to turn off all the automatic everything stuff and just depend on the raw power, the raw data rate of the radio to get my signal through there. I don't want it changing frequencies. I don't want it doing error correction because, as we say in the South, I ain't got time for no error correction. that data needs to get there, and so yeah. Hey, tell you what, we've got to take our break real quick. We'll be right back. Patrick Van Hoek is our guest.
No,
Chris Tarr
from Den.
I'm sorry, Van den Hoek. Sorry,
gotta post it. Write it down.
I'll write it down. I think I've got it. Here we go. I'll circle it and highlight it. And we'll be right back in just a second after this from Broadcast Bionics.
Camera One from Broadcast Bionics, designed to bring video to your audio content, visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera One is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need one camera for a studio wide shot and usually one camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera One's auto switch feature, or disable it and switch using the on-screen buttons or the buttons on the A10. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec Adam GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera One is a user-installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera One, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
And as thrifty and clever as Camera One is, it isn't the only thrifty and clever thing that Broadcast Bionics does. You can go to their website at bionic.radio, bionic.radio, and check out all the cool things that Broadcast Bionics does for us broadcasters. All right, Patrick Vanden Hoek is here with us, along with Chris Tarr. And Patrick, I'm going to shut up and let you continue your story about improving the STL. And I would point out that, you know, your radio station is on the air 24 hours a day, 7 days a week, 365 and a quarter days a year. And if your STL sucks or it's suboptimal, that's all the time that your audio is suboptimal. It's not just when you listen; it's all the time. Even when you're not listening, it's not optimal. So I think STL and processing and the quality, your audio quality is everything about your broadcast. And if it sucks, well, that's bad. So that said, Patrick, take it away with and
can I quickly answer a question from the Facebook Live? Is that okay for you guys?
Yeah.
Oh, yeah. So Elena is texting on the chat. She asks, what is LiveWire? Well, it is a type of protocol. Can I call it a protocol?
Yeah, it's an audio over IP protocol.
It's an audio over IP protocol, which is AES 67 plus compatible.
Actually, LiveWire was invented before AES 67, and so
and they made it compatible.
And so LiveWire, when we say audio over IP, we tend to imply that it's linear audio. It's not encoded MP2, MP3, Opus. It's not encoded in any way. It is a direct linear representation of the audio. It's the same ones and zeros that come off the hard drive or off the CD player. Sure, there's sample rate conversions, but basically it is as clean audio as you can possibly get. And all these AOIP standards tend to be typically 24 bits of bit depth. So it's and a higher sample rate than CD. So it's better than CD quality, goes over networks typically. But because the data rate is so high and the latency tends to be very low for live listening situations, we have to do some optimization so that the packets can get through really fast, really reliably in the right order. If you're going out to a transmitter site like you're doing, there is something called snake mode, where the device at the far end is a little more lenient in waiting for packets. It builds up a little bit of a buffer, like 40 to 100 milliseconds. So it can, if there's a packet that, I got here late, that packet will get stuck in the right place and will continue. So yeah, audio over IP is like the super turbo version of, MP3 or MP2, but it's linear and it's a little bit, as I would say, it's a little bit fragile. If you have an AAC stream, like streaming on the internet, you can lose 5, 6, 7, 8, 9, 10% of the packets, as long as they're
But
statistically
there's a huge
spread out.
buffer, so that wouldn't.
Well, you can actually lose packets, and the algorithm will smooth things out and give you some pretty reasonable audio. With audio over IP, if you miss a packet, you lose audio. There's no fixing algorithm. You got to get, and that's why you said, Patrick, LiveWire, AES-67, other audio over IP protocols were meant to go over a wired network because that's reliable. We know every packet's going to traverse the network. And with an IP radio, like you're talking about, well, we don't always know that. So we try to make the IP link as strong and good as possible. So that's my explanation. That's a great question. Thanks for asking, Patrick. Carry on.
Yes. So what I did as well after implementing LiveWire between the office where the processing is situated and et cetera, was to think about what if the STL or the IP radio link fails. I had a great solution to this. We have some MikroTik devices on our transmitters, which are router boards, which can do anything from VPN to everything a router can do, but then really advanced. The thing is, I hooked up a 4G LTE dongle to the MikroTik router that in case anything goes wrong with the LiveWire feed, in this case, which I monitor with PRTG, which is a monitoring system, available for Windows, by the way. It will automatically change over to a MP2 348 kilobit MP2 stream. You will definitely hear a little glitch there because it has to switch over, etc. But there will always be audio. If this MP2 thing fails, I have a 64 kilobit AAC Plus or high efficient AAC version 2 stream running as well. So we have 3 audio feeds on every transmitter site. And they all, of course, the LiveWire and the MP2 and the LiveWire and MP2 stream are not synced because there is a delay because we use a local IceCast server to distribute that audio to the internet. But in case the MP2 stream fails because there's not enough bandwidth or whatsoever, it will automatically change over to the AAC Plus stream. But without any delay. You won't even hear it because I've used the diversity delay, which is inside the Omnia 9SG, to correct that delay between the MP2 and the AAC Plus stream. So if anything goes wrong during a storm or rain, heavy thunder or whatever, and the IP radio fails, we always have audio. If that fails, we have a backup player, which is inside the Omnia 9SG, which just plays audio, etc. So we will, only if the power fails, we will never be off the air.
Wait a minute.
So
this is really clever. Chris, back me up here. So the Omnia 9SG, as well as other processors, have this diversity delay built in, so you can have your HD, your analog, your main FM delayed, so it matches up with your HD later on. But you're not using it for that. You're not using it for HD. You're using it to time align the almost instant LiveWire with the streamed audio, which is going to have X amount of delay because of buffering and so forth.
It has a constant bit rate, so the constant bit rates, it's 4.66 something seconds, the delay in the MP2 stream. Okay. And inside the MP2 has 5 seconds and the AAC Plus stream has 4.66 seconds of delay. So whatever, it works. It's perfect. I love it.
This is interesting. At one of my transmitter sites, which is a 13-mile or that's almost 20-kilometer hop over IP radios using LiveWire, I do have backup of the streams. I've got a PC out there that can decode the streams and provide audio to the audio processors, which are out there. And I don't have an automatic flip over. If the IP radio dies, the station calls me, hey, we've got 3 stations off the air. And so I just remote into that PC and tell it to move everything. So I don't have this instant flip over, so I don't have to worry about delaying one, 4 seconds over the other one. But that's really clever what you've done there.
What I did, I inject a Raspberry Pi, if we get into detail right now, that Raspberry Pi just gets in all the audio through 4G LTE data. Mm-hmm. It gets let's say a pulse, or how should I name it? It gets triggered by the PRTG monitoring system. I wrote a custom script for it that if a connection fails, it tells the Raspberry Pi to start streaming, because we only had problems with high pings, etc., which gives package loss, of course. So if there's package loss, we will instantly put on the Raspberry Pi streams, so they go out to the Omnia 9SG's analog inputs, and that is where the delay comes in for Livewire as well. So it is a really clever thing to do it like this, because the diversity delay is normally not used to delay any backup audio or whatsoever. But I was like, hey, there's a diversity delay. Let me just use it and see if it works out like it is working out in my brains. And it worked out. So whenever there's a failure on the Livewire input, it will automatically switch to MP2. And if the MP2 stream isn't stable as well, it will switch over to AAC plus 64 kilobit. If that's not stable, the backup player integrated into the Omnia 9SG kicks in. So I have audio always.
Good deal. Chris, that sounds pretty clever. I like that.
Yeah, that is. I never really thought about using the diversity delay in the SG for something like that. But yeah, that makes a lot of sense. That's really neat.
Yeah.
And because the streams have a constant bitrate, the delay is always the same. So
it is. Okay.
That's why I put 1 to, I use the VLC engine on a Raspberry Pi to get in the streams, put it out on just the integrated audio output on the Raspberry Pi. Mm-hmm. And in VLC, you can type in buffer. That buffer will stay on, for instance, the MP2 stream is 5 seconds. I know that because between IceCast, the source, IceCast, and the client in this case, this delay is always 5 seconds because it's MP2, the decoding process, etc. It's always on a constant bit rate, so I can rely on my 5 seconds. The AAC plus one, I get in with VLC, the library of VLC, of course, but on 4.66 seconds delay because I timed it. I was switching on and off, on and off. What is the delay? When am I not hearing the switchovers anymore?
Yeah.
And that's where the numbers came out. 5 seconds and 4.66. What was I telling? Sorry. The Raspberry Pi. So the delay is being done on the library of VLC on the Raspberry Pi. So I don't have to do anything at the end. I only have to delay my Livewire input because that is like, I don't know, I put it on 90 milliseconds or something, or maybe 100. And I cannot have a stream from IceCast with that delay. So I had to do something. And that's where the diversity delay came in. And I was like, oh, I'm damn brilliant.
I agree. I totally agree. That's impressive.
I bet there are people out there listening right now, and they're going to tweak their STL setup tomorrow with those ideas, and they're like, "Wow, that's clever. Let me do that as well." I bet.
You mentioned this product, the Omnia 9 SG, and that is really an amazing product. We're not here to sell it, but it does so many things that it's just amazing what you can do with it.
Well, it does it does many things, but it does those things in a good way. But that's my opinion.
Yeah, you're right. Hey, we've got to do something in a good way here, and that is we got to talk about Broadcaster's General Store, and from Broadcast Tools, we're going to talk about a little audio console from Broadcast Tools called the Pro Mix 4, and we'll be right back. And I promise Patrick is going to get around to his very clever alternate frequency plan his implementation to keep commercials so that listeners, instead of getting flipped to another station during a commercial break, they stick with the station that they're on. So that's coming up. I want to hear about that. ProMix 4 is, believe it or not, it's a mono audio console. It's not audio over IP. It's not extremely sophisticated. It's a small, diminutive little 4-input mixer that is perfect for taking to a ball game, for taking to a parade, a remote broadcast. Keep one at your transmitter site. If, my golly, plan C or plan D or plan E as you go broadcast from there. The ProMix 4 is a compact, full-featured mono audio mixing console, perfect for almost any broadcast studio, especially, well, like a voiceover studio. It features 3 combo mic line inputs. So the first 3 are mic or line level, and it has a dedicated 4th input that can be switched between a balanced line input or the built-in USB audio interface. So you can mix in audio that's coming from your PC. Maybe you're playing back files or intro music, outro music, bumper music, sound effects. Maybe you want to play an audience clapping because you don't have a studio audience. You can do that too. It has 3 1/4-inch stereo headphone outputs. That's included. And they have individual controls for volume, for mix, and for pans. You can mix, your local audio with return audio. And that allows custom headphone mixes. Other features include a switch selectable program limiter, XLR program output, monitor output with muting and volume control. It has a mix minus output for connection to an external telephone hybrid, and it also has an on-air light relay output. By the way, this is a great little console to connect up with one of our other sponsors' boxes, and that's the Bluetooth gadget from Angry Audio, so you can put calls on the air that way. It's a great choice for remote broadcast and podcasting applications. The broadcast tools ProMix 4. This is a little unsung hero of our industry, and you can probably put 1 or 2 or more of these to use at your broadcast facility. It is built for broadcasters, so it's built well. And I like the program limiter because your loudmouth sports announcer can shout out, "He shoots, he scores!" And if the limiter's clicked in, then you won't overdrive the output. Check it out from Broadcasters General Store. Their website is bgs.cc. bgs.cc. They are really set up to take your phone calls. So you spend all day on your computer, driving around the transmitter sites, not really interacting with human beings. You know what? It's refreshing to call the folks at Broadcaster General Store at 352-622-7700. That's 352-622-7700. Talk to Buck or Hugh or Candy or Candace, I'm sorry, or Jessica, anybody there. Really nice folks at Broadcaster General Store, except for Dave. Dave Kirsten, I don't know. Dave's a little weird, but he'll get your stuff to you. Dave's an interesting guy. Make friends with him if you can. Check it out from Broadcaster General Store. Thanks a lot for sponsoring This Week in Radio Tech. All right, Chris Tarr is here in Mukwonago, Wisconsin, and Patrick Vanden Hoek is here from
Hoek,
the Netherlands. All right, Patrick, we got to move on to this alternate frequency scheme of yours. Many radios in the U.S. don't actually respect alternate frequency. They're sold here without the expectation of actually having to work. So, but hey, 25 years ago, I was in France and this worked beautifully. Had a Blaupunkt radio. It actually had 2 tuners in it. One of them was you were listening to, the other one's looking around at the alternate frequencies and, would flip you over to it. So you have a lot of this.
Are you maybe are you by any chance saying that Americans are a little bit behind on that particular thing, like AF?
I'll tell you that we're very behind on a lot of that stuff.
Oh God,
RDS does. Oh, absolutely. Well, you figure, out in in Europe, there's a lot of same programming, small transmitters. They do a lot of distributed programming like that. Whereas in the U.S., we have things like the Class C FMs that are 100 kilowatts and cover large swaths of land. So you don't really need to do that. It's a very underused, mostly because there's really not a reason for it, unless you're talking about like a booster station or something like that. So, not only that, but we were really slow to even pick up on RDS in the first place. There's a lot of stations that still don't do anything with it. And, we haven't even really started with the RDS Plus. So, yeah, I would say we are very, very behind. But a lot of it was just because a lot of the things that they do in Europe, we didn't have to do. We didn't need.
Mm-hmm. Because you were using like this amount of power which doesn't need any AF or switching.
Yeah, I mean, we have the big footprints, and
you got a
generally
watch. You don't really need an alternate frequency. Well, you're gonna get it right here.
And generally, with ownership limits and those sorts of things, we didn't have commonly owned signals next to each other or anything else. So there just really wasn't a huge need for it.
Okay. Well, let's get into the ad break story Kirk was mentioning earlier. Well, the year I came to Spain, one of the most annoying things I discovered in that country is that almost all stations with edition splits or advertisement break splits, I don't know how you call them around in the US, but we call them splits, they were not synchronized. So I was driving around in a car with a good friend of mine there, and I was listening, and I was like, hey, is this a compact disc, a CD that has bad scratches on it, or what is going on? He says, no, this is normal. This is Spain. And I'm like, we, in Holland, in the Netherlands, we have multiple transmitters which broadcast only the same main national audio, but they're perfectly synchronized, and they don't skip like a CD or a piece of vinyl or whatever. And my main concern was, okay, so do we have the same problem? So driving around, listening to all the frequencies I have with the radio stations, and I was like, I cannot say the F word. There's no dumb button here, but you know what I mean. I was pissed because I was like, how can we do this in the Netherlands, but Spain just can't? What is going on? And they unfortunately explained me, on some locations we have an internet stream coming in. On another location we have a barracks device. The other location is satellite, and we cannot synchronize that. And I was like, oh, those morons, really. What are they doing? Like, am I back in the early 90s or something where we have ISDN lines, or I don't know. So the main concern I had was, how am I going to synchronize all those stations? And that is where Livewire came in, because like it has a PTP timestamp inside the data flow of Livewire. So it is always synchronized wherever you play an audio feed from Livewire. But that was later on. My challenge was not only to make it sound synchronized during our main playlist with music, etc., but also during ad breaks, I discovered that you were listening to an ad of a plumber, for example. Later on, there's McDonald's, and they were all scrambled, and was like, what is happening here? And in one car, it was poof, poof, and another car, poof, 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 poof. So my mind was like, what the hell is going on? Why is this happening to the radio? And I discovered, oh yeah, it's AF. There's a PI, a program identification code. And I was like, And then I started thinking, what if I turn off AF during the ad breaks, which a lot of stations do in all over Europe. I don't know if they do in the US, but turn off AF during the ad breaks. We have modern software, so we can tell the RDS encoder, hey, turn off your AF frequency list and turn it back on when the ad break ends. We call them macros or scripts to send to external devices to say, hey, TA bit for traffic announcement, or AF in this case. But the problem didn't went away. No, not in all cars. In some cars, it respected the AF list. And in some other cars, it didn't. What Kirk just told, like in the US, they don't respect the AF list. But in Spain, they have all types of cars, old ones and new ones. And some of them were respecting the AF list, some of them were not. And I was like, hey, I turn off the AF list, and I tried in several cars, but it was still switching to the best possible or best frequency in the area. I was like, I turned off AF. How is it able to switch or locate another frequency of the station I was listening to while AF was off, the alternative frequency bit on your RDS? And then I found out that there's another thing that car radios look at. It's called PI code, as we call it in a short way. It's called Program Identification Code, which has some bits in. I don't know if it's the same in the US, because you use letters, etc., and we use numbers, which correspond with
you can enter either way. Yeah.
What? Sorry?
You can enter either way, numbers or a hex code.
Yeah, but I was once logged into a DEVA in New York or something, and I only saw letters, no numbers. So I was confused, but maybe that's a US thing. I don't know. Yeah. So I was thinking for weeks, and I was like, how the F do I turn off the automatic switching in car radios? When I turn off AF, it's still switching. It's playing with my mind. I couldn't find out why. Then one day I just removed the PI code from the RDS signal during an ad break, testing, driving around. Problem solved. I was like, okay, let me try that in some other cars, because not all cars, let's say 9 out of 10 cars just stay tuned to the station you're on, but like the other ones don't. They just they put a message on a display, for instance, searching or scanning or whatever, because they don't see the program identification code anymore on your transmitting signal. And I was like, okay, the cars I tested it in where it didn't work out well were all old cars, like mid-90s or zeros or whatever. So I was like, I can do two things. I can just leave it the way it is and just have this awful sound of skipping between frequencies, or I can just convince people they need to buy a new car or a new car radio. I don't know. But I did the last thing. I just said, okay, 9 out of 10 cars, it works well with different car brands. And the old ones, okay, we don't talk about them. So I was like, yeah, well, you can just turn on the app and stream it through Bluetooth or whatever if you have problems with me turning off the PI code during ad breaks. So there are a lot of ways to listen to my stations in Spain. So I was like, okay, 9 out of 10 cars are fine. Okay, it's fine with me. And that's where I was like, okay, let me just delete the PI code temporarily during an ad break and just put it back when the ad break ends. And it works out perfectly. It's not skipping anymore. Works out perfectly.
Well, it's interesting in radio, and what you're talking about is fantastic. A lot of times in radio, we do things because we've always done it that way. It drives me nuts. And,
Yes.
Well, you got to have the PI code this way, and you got to have this way. And there's, why? Well, because we've always done it that way. Right. But is there a good reason? Well, yeah, we've always done it that way. So,
Yeah.
there's a lot of things like that I've done where I've kind of broke it and went, no, we don't have to do it this way. And you were mentioning
It's 2022. Where's your
right.
innovation?
I mean, we can figure these things out. We could put, we could put guys on the moon. We can do this.
Yeah.
So you were mentioning the PI code in New York. One of the things that I've seen is that a lot of the iHeart stations that run traffic, for some reason, their PI codes are changed and they're not related to the station. So whatever they're doing, it affects the PI code. But, honestly, I haven't seen a case where, at least in the US, where radio cares about the PI code. They all just do radio text. So, you can put the call letters or whatever in the text.
What do you mean by radio text? Sorry for interrupting, but what do you mean with radio text?
That is like the 64 character display.
Yeah, I know what it is. But it has nothing to do with the PI code, right?
Right.
Or changing frequencies.
Right. And that's what I'm saying is, the PI code, which translates here to the call letters of the station, is what they use the PI code for. The radios here ignore it. So we don't really need to use it for anything. So turning it on and off in our situation, you could leave it off, honestly, and radios
nobody cares.
Care.
Yeah.
Right. Yeah. I mean, because we use these other forms through the short message or through the radio text. Or I think it's PI or not PI, but the short 8-character display. We can do call letters or whatever that way.
Service.
PS, there you go. Yeah. I mean, we already in the US we already screw that up because we use it for title and artist and we scroll it. And,
oh no!
Yeah, I know.
Oh, yeah.
We break it out here all the time.
What station is this? Oh, Celine Dion?
Yeah, right.
Does she has her own radio station?
Yeah, but that's that race to the bottom. Some station somewhere, 15 years ago did that, and everybody went, "Oh my gosh, it's awesome!" And so everybody
we have to do it as well. Yeah.
Wow. Even though like every European RDS encoder that we buy says, don't do this, we all do it. So, but yeah, that's, it is interesting how, just to think outside of the box like that and go, why do we do that? Or why don't we, why don't we not do that? And I've you've solved a lot of problems that way. I know a lot of people have solved problems that way by just saying, hey, there's no reason, we can't do this, especially if it works. Somebody once said they're adjusting their processing and said, well, this number seems really high. And I'd say, does it sound good? Then who cares what the number says?
Exactly.
It's that kind of thing. We get so hung up on the technical details that we don't go, does it work? Well, then great. No problem.
Well, I think that I can speak for you as well. I think we are both really big nerds in problem solutions or finding solutions to a lot of common problems we have in broadcasting. And sometimes people think, oh, have you gone mad? What is wrong with you? But afterwards they say, hey, that's a genius. You're a genius. How did you find out this, that, and blah, blah, blah. So sometimes you don't have to do, like what you said earlier, the same thing you have been doing since whatever, the start of a station or whenever you came into radio or whatever. And be creative. Start thinking, what is happening behind the scenes? What is technically going on? How can we manipulate things to get there where we want to be, right? To solve problems
And I always tell the people that I work with, I value creativity more than anything. And, more than once when I worked for a large broadcast company, I was told, oh, that's not going to work. And I'm like, watch me, it is going to work,
and he did it.
Doesn't work. SNMP has been a big thing for that, where I've used it for so many different things, and they go, oh, that'll never work. And it's like, well, you don't know how powerful SNMP can be. It will work.
It is.
And it does. Yeah. So, we're our own worst enemy sometimes in the industry with that we're so afraid to try new things. And, really, if it's not broke, break it and then fix it again. I used to call it Netflix had something called the Chaos Monkey, where they'd purposely break things just to see what would happen. And they would break it in ways that they never thought it was going to get broken. And,
for example, turn off your transmitter. Turn off your transmitter, turn it back on. What happens? Is it booting back up, or is it broken, or is it, I don't know.
I always wondered who broke my Netflix DVDs before they got to the mailbox. It was the Chaos Monkey.
It's a true story, and just a quick little thing on that is they literally inject code into their system that does random things, and it acts like a user doing things that they never expected, and it breaks stuff. And that's how they learn what they need to fix, because they break things in ways they never imagined. And I like to do that. I like to, break things in ways that I wouldn't expect things to break, just to see how they fail. And then go, okay, I got to, figure out what to do when that fails that way. So it's a very good thing to learn.
Well,
Gentlemen,
speaking
whether it's
about
broken,
creative... Oh, sorry.
Well, we've got it. We're running out of time here. We're going to have to take a quick break. Yeah, look at the clock. We have a hard out at 13 after because Suncast turns into a pumpkin at 13 after the hour. So yeah, I know it's crazy. So we have to have you back again. Hey, whether it's broke or not, this will fix it. Yeah, this is my bag of Studio Hub stuff right here. Studio Hub cables, and they're in a bag because I made a little engineering trip about 3 weeks ago to Dallas, and I did some engineering things. Yes, they let me loose, and I used all these things to make up cables to do some important stuff at a big event. These are Studio Hub adapters to go from RJ45 to male XLRs to female XLRs, and this helped me make some cables and connect up some very important things when I was in Dallas. So Studio Hub cables are great. I did everything with no soldering. The last couple of studios that I've built for Delta Radio and for a Star 94.3 in Hawaii, no soldering at all, just Studio Hub to hook everything up. It's been great. And one more thing that Studio Hub has that you'll be interested in now is this headphone disconnector. It's a little headphone inline cable, but look, if your talent gets up and walks away, whoop, it doesn't.
Is it magnetic?
It's like a MagSafe, and yeah, and look, if you try to turn it around, like, well, I'm gonna turn around left and right. Nope, it won't go together that way. It only goes together the correct way. So left and right stay proper, and so it comes in that quarter inch, right? Anybody that's got talent that gets up and walks away, and it also comes in the 3.5 millimeter size. And guess what? You can also mix and match. So you can actually take a 3.5 millimeter plug, and if your headphones, have quarter inch, you can do that, and you can do the opposite too. Wow. It goes, so you can mix and match these things, and they're great. I talked to an engineer about 2 weeks ago who told me that this actually saved him from having to repair a circuit board and a quarter inch tip ring sleeve connector. So great stuff.
So the large and the small. So it does country and western.
It does country and western both, yes. Check out angryaudio.com. There's the website, angryaudio.com, to check out the Studio Hub gear. They got a big PDF that has all your Studio Hub adapters on it. You should check that out. Seriously, you really should. Thanks a lot, Angry Audio, for sponsoring This Week in Radio Tech. You can get Angry Audio stuff from your favorite dealer, but you got to ask for it. Ask for Angry Audio. Don't accept a substitute. Ask for Angry Audio or Studio Hub and get the real stuff. Hey, we're going to take a quick break and hear from our friend John Takak about Max Connect Wireless.
With all of the recent cybersecurity attacks against large corporations, we were looking for a product that would give us the ultimate security at our transmitter sites and as well as with our broadcast equipment. Max Connect fits the bill very well. Its greatest security feature is the fact that it gives you a single static IP address. Using this single static IP address allows us to close hundreds of open ports on our firewalls across the company and restrict access to only the Max Connect IPs. This has greatly reduced our exposure to the World Wide Web and made us much more secure moving forward. It's also given us the ability to expand as needed in a secure fashion.
Thanks a lot, John. Max Connect Wireless is the product, and you can get one in a Cradle Point 4G LTE modem like this one, or in a PepWave. It really doesn't matter, the 4G LTE modem. What matters is the SIM card from Max Connect Wireless, and you can get this service with your favorite carrier, AT&T, T-Mobile, Verizon, or Sprint, which is part of T-Mobile now, and also it's available in Canada as well. So get that. Check it out. The website, maxconnectwireless.com, or they've actually gotten the shorter version, Max Connect. I know it's spelled funny, but there you go. Max with 2 X's, connect with a K.com. The link is in our show notes. All right, we got just a couple of minutes here. We're looking for a tip of the week. I, of course, forgot to tell Patrick about this. So, Chris, if you have a tip of the week ready to go, maybe you could tell us first. Give Patrick a moment to scramble and think of a tip of the week.
Well, now I've got to scramble to think of one. I could actually SNMP. I'll do a quick tip of the week. If you haven't learned already, learn about SNMP. It is a simple network management protocol, and just about every device nowadays speaks it. And a great quick example of how I'm using it is I put in a Burke remote new Burke remote control unit, their new Arc Plus box, in one transmitter site. Now, all of my sites and all my buildings are connected together using VPN. I can use that one box, and I can actually monitor all of my translators through SNMP over the VPN with one remote control and control them all at all these different sites. So I'm not having to buy a remote control for each site. It's all done through SNMP. It collects all that information, and I get a whole row of meters for everything on my network. So, something that not a lot of people do yet. So if you haven't yet, learn SNMP.
You've got some education about SNMP, through SBE, don't you, Chris? And did you do a webinar or something?
I did, yeah, about how to use it for, this was a while back, so I'm not even sure where to find it in terms of time frame. But yeah, I have discussed it before, and I don't even wire transmitters anymore. I will actually buy things that have SNMP in it so that I can connect it through the network.
I'll find a couple of resources, the things that you've done or that other people have done specifically for broadcast. SNMP is, throughout the IT industry, but it's interesting to think about it directly for broadcast and our broadcast equipment that we use. So I'll put that in the show notes. I'll find some stuff and put it there. Chris, if you know of a resource that you'd like me to put in the show notes, send that to me tonight, and I'll put that in the show notes. And Patrick van den Hoek has a tip of the week for us. Patrick?
Well, not exactly a tip, but maybe an advice is that stay away from encoded audio. Go linear, join the club, and it also has positive effects on your audio, like in reception, not in sound, but in reception on your transmitter. So go linear, join the club, and be part of the world of linear audio. I don't have another tip, but this is what I would advise to anyone.
Hey, look, we used to, encode all of our songs in MP2 or maybe even MP3 because hard drive space was terribly expensive. Well, now, and for some years now, hard drive space has been way cheaper than encoding technology. So there's no reason to have your music, still encoded. There's no reason to get your music from File Donkey. Although, that's been 15 years, 20 years ago. Or Kazaa. You brought up Kazaa earlier.
LimeWire.
LimeWire, yes, of course.
Yeah. Of course.
There still is a place for coded audio. Sometimes the first mile, like from a remote broadcast, if you need to go over connections where they're not going to carry a linear audio, that first mile. And then sometimes the last mile, that would be in encoding a stream. So my radio stations, everything's linear until we get to the stream encoder for our internet listeners. And I can tell you, they sound amazingly clean because you're not doing what's it called? Transcoding.
Transcoding.
Yeah,
or cascading codecs or
cascading. That's it. We're not doing any cascading at all, unless we have a remote that's coming in, at some bit rate. And then we manipulate it within the studio building as all linear, and then it goes out the stream as encoded again. But we try to use different algorithms, and we definitely always use the highest bit rate possible, especially for contribution audio. Yeah.
Well, maybe just a good tip is to use for if you're on remote. And you have to use a stream in MP3 or MP2 or high efficient AAC plus or whatever. Make use of the Perfect Declipper by Hans van Zutphen. It has the delossifier built in as well. Run it through Pro Tools or Adobe Audition or whatever. Run your stream through it and make sure to output it on your mixing console, of course. So you get rid of the on the MP3 or encoded audio. I think that's a good tip to do because no one does that, I think. It's called perfectdeclipper.com. It is not expensive at all, but it definitely does a great job.
And there are some audio processors. I actually think the Omnia SST, which is has code from Hans von Zutphen, I think it has delossifier available in it as well. But perfectdeclipper.com. By the way, I'm using a new shampoo that has a delossifier in it.
I see it.
We gotta go before the jokes get any worse. Patrick, thank you for being with us. I appreciate it very
much. As we say in Holland, we say fijne avond. It means good evening.
I was going to say the same
have a
thing.
Great night.
Okay, Chris Tarr, thank you for being
Buenas
with us.
noches.
I appreciate it, buddy. And we owe a big thanks to our producer, that is Suncast. Thank you, Suncast, for producing another great show. Hey, next week we're working on having this geocasting information with us. We got some information. That technology's coming along, and people are starting to put that to use. So yeah, geocasting. That's going to be pretty interesting. Thanks, Patrick, for that. Gosh, we'll see you next week on This Week in Radio Tech. Bye, friends.